Hi and welcome to another screencast in the Creating Sample Sets for GroundOrg series, in which I will talk about recording techniques. So, at first, we should examine a little bit the source we are going to record. The pipe organ mainly consists of flute type of pipes, like this one that is an open pipe, and you have a mouth here. As opposed to, you can also have the type of like this, that is a stopped pipe closed at the top. And the sound emission will be a little bit different depending on the pipe types, just for information really. But you will see that it has some bearing actually on where you optimally should place the microphones. So there has been some research done on this, where the sound actually comes from a pipe. Here you have an open pipe, like I showed first, where the mouth is here. It's facing this direction, and you have sound emission mostly from the mouth and from the top. But actually the whole body is vibrating and contributing to the sound emission. For a stopped pipe, you have mostly sound emission from the mouth region and some from the body too, but not so much at the top. But you see that it goes quite sharply raising where the sound will go. That should be some indication. However, with open pipes, you have to be really careful, because if you end up right in the middle of the pipe, you might have the situation where frequencies are actually cancelling out, because you have both from the mouth and from the top, and right in the middle you might have some frequencies that actually cancel out. So that is something to keep in mind also when you are placing the microphones, or to listen for. You also have reed type of pipes, from which mostly the sound emission comes from the resonator and resonator tops, but it might differ so much how they are constructed that no hard rules really can be given, but from the resonator there too. Okay, so we can have another look at how the sound is projecting. This is a closed pipe, and this is an open pipe where they have measured. In a room without any reflections really, so this is the direct sound of the pipe that is recorded and compared. So just keep that in mind, keep this image in mind when we are going further. So when we are recording, I would highly recommend that you get some sources. I have used the Stereophonic Zoom by Michael Williams, and also from DPA microphones, their stereo recording techniques and setups that contain some pretty useful information. So I highly suggest you get those sources and read them if you are interested in this topic. So if we go to the DPA source here, the microphone as such, when you're getting closer to a sound source, it will be louder, of course. And if you back up, it will be softer until a certain limit where you will find that the sound level is not dropping that much really when you're moving back anymore. And that is actually what we call the critical distance, or around there. But that is actually a pretty complex subject. And it's not that easy to apply with a pipe organ with thousands of sound sources, thousands of pipes that we are in fact recording. So the critical distance would be where the direct sound from the pipe and the reflected sound from the room would equal each other. And if you go further away, you will be in the diffuse kind of field. And if you go closer, you will be more in the direct sound field. This is not something that you can calculate absolutely if you're not very has some information about the room, because every room will be different, and depending on the surfaces in the room, this will be different. So it's really best to use your microphones as a source and listen to them when you are placing them to find out the correct position, and not only using kind of theory, but rather practical. So when we are recording in stereo, at least with 2 microphones then, and sometimes the multi-channel sample sets actually consist of multiple stereo recordings, stereo tracks, multiple stereo tracks. So you have multiple positions where you have had microphones placed. So a stereo recording, when 2 microphones are used, you can have difference in either level or time when the sound reaches to them, or a combination of that. And that is what creates the stereo effect. Normally, in the theory books, we are supposed to have a listening situation like this. Not everyone has this kind of setup, but that is what they are kind of using as a reference. When using headphones, you might not get exactly this kind of listening field, actually. You should be aware of that. Michael Williams has written a little about that in the Stereophonic Zoom. So a proper setup might actually sound much too wide in the headphones. So the headphones should be used to decide the overall audio quality, not the stereo spread, actually, that we are going to talk more about later. So when we are talking about stereo setups, there are a few. Mainly, I have used 3 types of microphone setups. There are more, but I have not found really a use for them. But these three types I have used. So the first one is what they call the AB setup. This is very simple to do. You basically take 2 microphones, put them parallel to each other, pointing to the sound source at a certain distance in between them, and record. So in this document, they have written a few things that are important whenever you're recording. The first step is to select the distance between the sound source and the microphone setup. Yes, so how do you do that? Well, this is actually the key. Also, individual preference. That is, what do you want to hear? So listen to what the microphones actually pick up when you choose the placement. So if you go closer, then you will have more direct sound, and if you go further away, you will have more reflected sound. So decide what you're going to use. With the AB setup, mostly this is used with omnidirectional microphones, and they can be used quite efficiently to capture the room characteristics. We are actually dealing with time difference here and not so much level to achieve the stereo image. So, well, you pick a distance that is appropriate for the sound you want to make, and then you pick a distance in between the microphones. You have a help here that if you're kind of wanting to reproduce the sound image on the normal stereo setup, you should follow this dotted line, dashed line, and these values are the distance in between the microphones, and here over you have the recording angle. That might require some explanation. The recording angle is usually notated with a plus and minus. So you imagine the distance from the leftmost source. Oh, I don't find it now. The leftmost pipe to one side and the rightmost pipe to the other, and then you have the distance to the microphones here. That angle that covers all this field, that is the total recording angle, but this is usually divided in two. You place the microphones in the middle, and then you have divided the angle into a plus minus here. That is the stereophonic recording angle. So when you know that, you can just choose appropriate distance between the microphones. And you see 70 here, 60, 50, 40. Usually the recommendation is somewhere between 40 and 60 if you read the literature. So that is the AB setup. This is very easy to use, actually. So experiment with that, especially if you have omnidirectional microphones. The next setup that is pretty easy too is the XY setup. So here you have two microphones, usually cardioid, that are placed in roughly the same spots, as close together as possible with the capsules of the microphones. And then you have them at an angle. Usually we see the 90-degree angle, but this is actually also variable depending on what field you want to have, what recording angle. This classical 90 degrees to each other will give you 180, a sound feel of 180 degrees actually. So this is usually appropriate for very close miking, a microphone placement. However, if we go very, very close, we have to be careful because you might have weird organs. We have the problem of a big spread between the sound sources. So you might have some sound sources that are very close, and in the same rank you might have others that are very far away. And the level difference and the amount of, the proportion, I should say, of direct sound and reflected sound might differ too much in that rank, so it won't sound really natural. So you will have to experiment with that, checking the closest pipe and also the one that are most far away to achieve a good balance. So cardioid microphones, and we might vary the angle also here depending on what recording angle we are going for, really. So the most common versions I have seen is the 90 degrees in between the microphones and the 120 degrees in between the microphones. But this can be varied, of course. But you get the capsules close together in this system. So you will have mostly level differences and not time differences. And then there is a third type of setup that is basically called near coincident, and this is not one but many versions that are possible. So you have some famous names of different setups that all fall within this category, and this is actually what the whole Michael Williams document is about. So you have, again, here is the listening situation. Basically what you have is a setup where you vary the distance between the microphones and the angle between the microphones depending on what stereophonic recording angle you wish to achieve. And to help you with this decision, he has various diagrams depending on the type of microphones where you optimally should have the distance between the microphones and what angle should be to achieve a certain stereophonic recording angle. I should note that this is no hard rule, but a guideline kind of to help you get things appropriate. There are reasons sometimes to deviate from what would be perhaps theoretically the best, but you want to achieve something else. Why this matters is that when we are recording something, I should make this a little bit less in size. We are actually, this is the stereophonic kind of recording angle we are talking about, leftmost and rightmost, and we want to have what sound sources we have in this field represented approximately in the same way when we are listening through the speakers. So that is why this can help quite a bit to avoid having distortions where you will have, if you're going very much off the optimal placement, you will have situations like here, that you have recorded something, but when you're listening to it, it will seem that they are displaced kind of from where you expect the sound source to be. So this theory is all good and well, and I suggest you should experiment with it. But when it comes to practical application, it will be almost always best to use your own ears and thinking about what do you want it to sound like. Use your own ears and your own judgment. This can be of help, but no hard rule. Unfortunately, it's not that easy that you can say always be within, say, 2.5 meters from the pipes or from the facade of the organ. An organ can be very different And we are actually not sampling only one pipe, we are sampling the whole instrument, even if we are recording a pipe at a time. And depending on how this organ is, it will be either difficult to achieve a proper image, stereo image, or it will be easy. But, well, yeah. In a small organ that stands on the ground, it's pretty easy. If it's compact, you won't have that much of a difference between the pipes in here compared to the front ones, unless you're very, very close, of course. But if you move a little bit away, then you will soon find a place where, okay, this gives a good balance, simply. On the other hand, most organs are on lofts and pretty high up, which means that it could be more difficult. You might have, like in this organ, a root positive that will be much, much closer than the main organ, and then the Oberwerk up here, and then you have a pedal behind all this. Sometimes the organ will be very deep also. You might have a swell behind the main organ, and then you will have the pedal further back. So this all makes it more difficult to get a even position with just one microphone setup. But if you have too many and too varied, then you might have issues between in the ratio between direct and reflected for the different setups, and it can sound pretty strange too. So again, we will try to experiment in another video with using these kinds of setup, but for this, mainly keep in mind the sound emission from the pipes. Ideally, you should be somewhere above the mouths. Avoid the middle of the pipes though. And you have basically three type of microphone setups: the AB parallel, the XY that is at an angle very close together, and then you have the near coincident that uses a varied system for this. If you have the possibility to record in multi-channel, then and the resources to have multiple setups at once, you can of course use them all together and get the different stereo settings or the stereo positions at the same time, and then you can compare it. If you use all of them, the user will have the possibility to decide, okay, I like this more than that, or I want this kind of combination where this is a bit stronger and this is a bit softer. That is basically the advantage of using a multi-channel sampling. So that is it for this screencast. Thank you for watching and see you in the next. Bye!